Kyle Smith.
And I'm Quentin Lentz.
Hello, my name is Nathan Doctor.
And this is
A New Tech Production.
For physics.
Who's got the gavel now? Who's got the gavel now?
And today we're going to be talking about rocket designs,
The Voyager.
and the International Space Station.
Let's get started. First, we have Hal with
Rocket designs. And the formula that'll be relating to Quentin and I's research is escape velocity.
And the formula for escape velocity is the square root of 2 times the gravitational constant times the mass of the body divided by the radius of the Earth.
A lot of physics goes into today's designs for rockets. First thing is thrust. Thrust is basically the amount of force that is applied to the rocket to get it into space.
Cool.
The higher the mass, the higher the thrust must be. Second thing is propellants. Propellants is a kind of fuel that is used. There are several different kinds that I'll tell you about. And last but not least, we'll discuss why is mass important. Okay, with propellants we look at Newton's third principle when it says that every action has an equal opposite reaction. The propellant in this case is the opposite reaction to the rocket, which is the action, which is moving. As you can see in this picture, you can see the propellant as the hot gas moving away from the rocket, which in turn is pushing it. And the propellant also provides the thrust for the rocket. How that works is the propellant is either burned or pushed out of the rocket. When it's burned with an oxidizer, which provides large volumes of hot gas. The hot gases expand until they rush out of the back of the rocket, along with the unburned propellant.
Wow, I didn't know that.
The types of propellants that are used are either solid fuel chemicals, liquid fuel chemicals, or cold gas chemicals.
Talked about propellants. Now let's talk about thrust.
Thrust is the amount of force that the rocket engine provides to move the rocket. It plays the key stage when it comes to the launching phase. As you can see here on this picture, there's obviously a lot of thrust being used to take the space shuttle into space.
What?
The way we can find out the speed of the rocket with all this thrust is by simply comparing the speed of the propellant leaving the engine to the speed of the rocket. That's all there is.
That's cool.
I know, right? Another thing we can do is find the momentum of the rocket going forward by simply taking the momentum of the propellant leaving the rocket and subtracting the amount of resistance. Now let's talk about why mass is important and also talk about a key contributor to rocket science.
Cool.
I don't even know where to go here. Look at this. There's 900.
Mass is important in rocket science because it determines how much thrust is required to get the rocket to the correct escape velocity so that it can leave Earth. Wernher von Braun, a Nazi scientist,
Wow, what a jerk.
created a V-2 rocket for war efforts that was later used on England during World War II.
Really?
Yes. After the war, von Braun started working for the U.S.
Nice.
He first worked for the ICBM.
What exactly is that?
That is the Intercontinental Ballistic Missile Program.
Oh.
Yeah, I know, right? And eventually, he worked for NASA. And later on, he was a key person in designing the Saturn V rocket, which was the rocket that launched Apollo 11 to the moon.
That's so cool.
I know, right? About the Voyager from Quentin.
Voyager 1 launched in 1977. Then it went 30,000 miles per hour through space all the way to the end of our solar system to discover it. And the Voyager 2 was then launched, going to the same area. Whatever. I don't know. As I said, 2 spacecrafts were launched from Earth in 1977 and hurtled through space at more than 30,000 miles per hour. At the same time, important advances were being made in science of gravity-assisted orbital trajectories. While the math and physics involved are pretty complicated, the basic idea is that a spacecraft can use the gravity of a nearby planet to give it a larger boost in velocity, as long as the spacecraft follows the proper orbit. The higher the mass of the planet, the stronger the gravitational force and the bigger the boost. So this is a diagram of one of the Voyagers. As you can see, a lot of precaution is taken because it exits the solar sphere. And it doesn't have a sleek aerodynamic design because there's no sort of friction in space to worry about. The primary mission for the Voyager 1 and Voyager 2 spacecrafts are to explore the outer planets, which include Jupiter, Saturn, Neptune, Uranus. And the Voyager 1 and 2 found volcanoes on Jupiter and Saturn, and different moons in Saturn's rings, and also explored the outer regions of our solar system.
Now let's go to Nathan Doctor with some information about...
Now for the most important part, I did a study on the International Space Station. The equation I will be using is orbital velocity for the space station is orbital velocity equals the square root of gravitational constant times the mass over the radius of the Earth.
Hello, my name is Mitt Romney, and I approve this message.
For the International Space Station, the first idea came actually in 1929. Obviously, they could not have the materials or any way to get into space. So, the actual space station was not launched until 1998. As you can see, there are a lot of parts and pieces to it. The parts and pieces were not put together until 2011. Today, the space station orbits 370 kilometers away from the Earth's atmosphere.
Wow.
That's amazing!
It is orbiting at a speed of 7.71 kilometers a second. That was calculated by the formula that was given earlier.
No way!
The International Space Station has made many discoveries and has many more in the future to come. Mainly they're in the area of medicine, weather, and astronomy. They are working to discover new safety regulations and the effects of gravity on humans. They also, when there's no clouds covering the Earth, they can study weather patterns, the effects of pollution, and other environmental aspects of the world below them. Okay. Using the International Space Station, they have made discoveries on how to send robots to Mars and other places in the universe. They've also found many medical ways of curing cancer and other major diseases.
Hi.
Okay, stop! Let's give
Some credit.
To our sources. These are the sources that I used while studying the International Space Station.
And these are the sources I used while studying the Voyager.
These are the sources of information that I used while studying rocket designs and how they work. Thank you for joining us on Physics Today.
This school will self-destruct in 20 seconds.